From the first two techniques, that is, the definition of R of P and the expected value of phi of x, you might conclude that all you need to do in order to write down a reliability function is just take the structure function and replace x sub I with p sub I. That's not the case, and you'll see why here in the third technique, which is known as the path vector technique. So here is the strategy associated with the path vector technique. All you need to do is sum the probabilities corresponding to path vectors. So the reliability function R of P is the probability that x is a path vector. Notice that these are path vectors, not min path vectors. Here's an example. The 2 out of 3 system has a structure function that looks like this. That can be found by drawing the reliability block diagram of a 2 out of 3 system with repeated components. There are a total of 2 to the third, or 8 possible system state vectors for this system. Of those 8 system state vectors, it turns out that exactly 4 of them correspond to an operating system. Notice that in all of those cases there are either 2 or 3 operating components. So to find out R of P, we want to find out the probability x is a path vector, and so we sum the probabilities. 0, 1, 1, the probability of being in that state is the first term. 1, 0, 1 is the second term. 1, 1, 0 is the third term. And finally 1, 1, 1 is the fourth term. Now, if you want to simplify that and shorten it a little bit, you can multiply it out and you get P1, P2 plus P1, P3 plus P2, P3 minus 2 times P1, P2, P3. That is the reliability function of a 2 out of 3 system. Here is another way of looking at it. It says try using the expectation technique to find the reliability of a 2 out of 3 system. If you take the naive approach, which is also incorrect, and simply take your phi sub I function from the previous page, and everywhere you see an x put in a p, you would get this reliability function, which is wrong. Why was that wrong? It turns out that phi of x contains product terms in it, such as this, which means you're going to be calculating the expected value of x1 squared if you are using the expectation technique, and that is not equal to p1 squared for a Bernoulli random variable x1. So because of that, R of P will not be correct using the naive approach. Here is the correct solution using the expectation technique, which is technique number 2. It always starts with the first step, which says that the expected value of phi of x is the reliability function. Then what you do is you put in phi of x for a 2 out of 3 system, and that's this step. The third step, you multiply that complicated looking function out, and when you do, you get this long series of expected values. Now this is easy. If you have the expected value of x1 times x2, well, that's just going to be the expected value of x1 times the expected value of x2, and that's what leads you to the P1, P2. But that won't be so simple when you have a squared term here. Turns out the expected value of x1 squared is just P1. So here is the appropriate way of calculating the reliability function of a 2 out of 3 system. using the expected value technique. When you shorten it up, you get exactly what you got on the previous page, so they match as they should.